In this exercise 6E3, we'll look at 3 integration formula, and the first one is this formula. It's very similar to chain rule of differentiation. It's very useful for problems like this too. Let's look at how we apply the formula. Let's work with A here. Right, so first we need to identify A and B and the N. But firstly, it's very important that the N, that the exponent not equivalent to -1. Otherwise, this formula will not work. So if you look carefully, the A here is 2, right? The B is 5, and your N is 3. So according to the formula, we just very simple, 2x plus 5 is going to be n plus 1. So in this case, 3 plus 1 divided by 3 plus 1, and the A here is 2, so just multiply by 1 over A and plus C, and you're done. And of course the A here is 2, and we need to simplify it. We should do not expand this and keep this at power 4 is power 4. I mean, this is 4, and simplify further. This is half times this rational expression, and you get 8 plus C. Okay, now the next one, B, and this seems to be really difficult, right? However, if you use a little bit of algebra like this, it becomes -2. Immediately you see that this, you can apply this formula where n is -2, and your A is also -2 incidentally right here. So there you have it, 1 over A, or 1 over -2 times 2x minus 2 plus 1 minus 2 plus 1. Do not forget the C. If you simplify this, you have -1 over 2. This is -1, and this is 3 minus 2x -1 plus C. You can simplify this further to get 1 over 2, 3 minus 2x plus C. Right? Is that cool? Now moving on to questions like this. This is very similar to questions that we discussed just now. I'm just going to do A. I will talk about D a little bit, but I will not do it. But just by writing a 3 in front, remember the property we discussed in one of the earlier exercise. You have this. So I'm going to do this directly. I put brackets to avoid confusion. So this is 2x minus 1, 2 plus 1, 2 plus 1, 1 over A in this case 2, plus C. So we'll have 3 over 2. This is going to 3, 2x minus 1, 3 plus 3c. Well, 3c is just another constant. Well, we're going to call it c1. Okay, and eliminate it. So we have half 2x minus 1 power of 3 plus c1. Right. The D, just going to explain a little bit. Will not do it until the end. So what you're going to do is you need to expand this. Yeah, you just expand this, and to get a 2x square plus x power 4, and then use this fact to help you continue your integration. Alright, moving on. It's a bit different. Two other formula, one involving ln, the other one is ex. Work with a here. You can treat this integral like this: ex dx, the 2 in front, and 5 integrating e2x dx. And according to formula, we don't see a b here. B here is 0, but for this integral is 2ex, and for this integral e2x, according to the formula, is 1 over 2. And notice that a is 2 here, so e2x plus big C. The C is just for both. We just need one C, that's all. And you have 2ex plus 2e to power of 2x plus C. Right? And this one, D, is a bit tricky. If you look at this carefully, this we can use this formula to help us. And a in our case is 2, b in our case is -1, and exactly it will be equivalent to 1 over a ln ax plus b plus c in this modular sign. But what is a? A in our case is 2 ln 2x minus 1 plus c. That's all done. Moving on. There's another one. Okay, I'm gonna do this one. We're going to use this formula again, but something extra is needed. I have to show this part first. So just algebra. Try the left hand side. As you show, you must start from one side. I choose left hand side. Factor is x minus 2. So the first rational expression at times this. Okay, so to make sure they have the same denominator. And as for this one, x minus 2, I'm going to times x plus 2. So now notice that both terms will have the same common denominator. Of course, you can't just simply times x plus 2. So because this is 1, and now let's combine them. Be careful of a sign, and you do this correctly, you have 2x minus 8, and if you expand this is equal to x squared minus 4. Done. Right, shown. So hence find this. So they ask you to find this, and you realize why at first they ask you to prove this identity, because now I can write this as follow. because we have shown that this rational expression is similar to this here, so we can express as follow and perform the integration separately, and just use formula here. This will be ln x plus 2. Do not forget the absolute sign. It's very important that you keep the absolute sign, plus c. So that is what required. And hope you do the other questions, the exercise, and to improve your skill.